Everyone, welcome to another video in IGNOU's classroom. So in today's video we are going to discuss one important question from MMPC 5, that is quantitative analysis for managers. Okay, so let us get to the question. The question is, what do you understand by probability sampling methods? And it is asking us to explain the various types of probability sampling. This question is from your term and examination which happened in December 2021, so last year. Okay, this is we are going to write December 2022's examination. This came as a 15-mark question in that question paper in section A. Okay, so how do we write the answer for this question for around 15 or maybe 20 marks is what we will see. So this structure actually we can apply for many of the theory type questions. Okay, and if you are someone who is a bit weak on the problem part, okay, if you are not finding if you're not able to easily grasp how we can solve a question, okay, happens most of the time. A good strategy to get good marks would be to concentrate on the theory part of this. Okay, so MMPC 5 as well as 4, accounting for managers, both of them, though it is a problem paper, ample amount of theory questions also have been coming. That is the trend we are seeing so far. Okay, so if you study the theory completely, the complete theory also, if you know, you will easily get passing marks, especially with coupled with your assignment marks. Okay, so for this particular question, we can divide our answer into at least 5 sections. Okay, that is, we can start with writing what we understand by probability sampling methods. Then what are the different types, what are the advantages and disadvantages of them, what are the steps we can follow, when can we use this probability sampling methods, or when do we usually use this. Okay, and then we'll go and explain each of those probability sampling methods with an example. So that will be ample enough material to at least fetch you 15 to 20 marks. Okay, so this, I would suggest that this approach is the best to be taken for any theory type answer. You explain what you understand by it, then go and say what are its use, where can you use it, what are its advantages and disadvantages, and give a few examples of how you can use these things. It is a very good structure to get marks in theory. Okay, so the definition: probability sampling is a technique in which researcher chooses samples from a larger population using a method based on the probability theory. Okay, so for a participant to be considered as a probability sample, he or she must be selected using a random selection, and therefore this probability sampling we also call as random sampling. Okay, so all the different types of probability sampling is one way or the other a random sampling itself. Okay, and therefore the most critical requirement of the probability sampling is that everyone in our population has a known and equal chance of getting selected. Okay, because it is random, the probability of any of your sample, any sample from your population getting selected should be equal. Okay, probability sampling uses statistical theory to randomly select a small group of people, that is what we call a sample, from an existing large population, and then predict that all their responses will match the overall population. And as a rule of thumb, we generally take sample sizes over at least over 30 if you are going for probability sampling. If you don't have enough population to get yourself at least 30 samples, then we go for a method that is called non-probability sampling. Okay, this is what we go for in case we cannot get at least 30 samples. Okay, so that is not, this non-probability sampling is not uh, a part of our question answer, therefore I'm not going into that. Okay, now when can we use these probability sampling instances or probability sampling methods? When we want to reduce the sampling bias. Okay, that is, we need to give each of our population an equal chance of getting selected. Okay, when there is a very diverse population. Okay, and to create an accurate sample. Otherwise what will happen is that we may tend to apply our own internal biases. What are the different types of biases and all those things we had actually learned in business communication. Okay, so I'm not going into that. It is, biases are more or less kind of the same only everywhere. The way we talk about those biases or the way we name such biases might be a little bit different depending on the concept, but the underlying principle is almost the same only, so you can understand biases from that. Okay, now to conduct probability sampling, what are the steps we must follow? First and foremost, we should choose our population very carefully. Then we have to determine a suitable sample frame and select the sample frame, in the sense we need to determine what kind of sampling method or the sampling type we are going to use, and then we select the sample based on that method and we start the survey. Now, what are the types of probability sampling? There are actually 4 commonly used types of probability sampling designs. There are a few more, but very rarely used. So for our answer, we will stick with these 4 generally used and generally and most widely used probability sampling designs. Okay. The first and foremost is a very simple random sampling. It is completely random method of selecting subjects. You have a population, you randomly select a few, right? Just like you have a bag of rice and then you just put your hand and then just pull out a few, right? You just mix everything up, okay, and then you just pull it out. So it is a random sample. Then we have stratified sampling, which involves splitting subjects into mutually exclusive groups and then using simple random sampling to choose members from groups. So it is like, suppose say you need to get the salary, okay. You need some data about the salary of men and women working in an organization, okay. So we can stratify the group rather than simply selecting randomly, in which case there are chances that you might not have any population actually, I mean, getting represented properly. Like a random sample, if you use a random number generator also, there is a chance that maybe there could be a skewness of in your sample. Maybe there are chances that maybe more number of males got selected or maybe more number of females got selected. We never know, right? So what we do in order to avoid that is we split our population into men and women, and then from each group we will apply random sampling and then take enough samples. That is stratified sampling. Then we have systematic sampling. That is say for example you have 100 people. From that you need to select 10 people. So first we will do is maybe we'll select the first person, then we select the 10th person, then the 20th person, 30th person, like that. In that way it is called systematic sampling. That is like you're choosing every nth participant from a complete list, okay. Then we have cluster sampling. That is randomly selecting participants from a list that is very large for simple random sampling, okay. So suppose if we have a much larger sample population and from there we have to gather data, means we go for cluster sampling. Now, what are a few advantages of probability sampling? Why are we actually going for all these things? First and foremost, it is very cost effective, because if we have to apply, like when we were talking about the application of mean, median, mode and all, we saw, right, I had shown a actual working sample with sample data. I had shown how we can calculate. Suppose our population is very large, okay. In that I had used an Excel sheet to show you the calculations. Suppose our Excel sheet is very large, the file is very large. What will happen? Right, it will become very difficult for us, right? So what we will do is we will just select a few samples from the population and then we'll apply all our calculations or all our statistical methods and probability models and everything on those in that sample population, assuming that sample is a good representation of our entire population. And then once we train our ML models, we will what you can say, we'll remove the sampling and we'll apply our training model into the actual uh, testing data. That is what we do, okay. So it is actually when we do the ML models and all, ML means machine learning models, we do that, okay. Actually we do that in practice in our jobs, like in the profession. ML models, we do that. We take maybe, like, mostly we generally go for around 10,000 samples. That is the standard. We can go for more than that or less than that, okay. Like we have software tools like Data IGNOU, Alteryx and all, which and many other tools, Power BI, Tableau and all, which help us do these kind of ML training on our data sets and all. In case you're interested to learn more about it, let me know in the comment section, okay. This is something apart from your MBA actually, but in case you're interested to know about it, let me know. I'll see which tool I can take a demo on, okay, and show you how we train actually these ML models. Anyway, let us go on, move ahead with our answer, okay. So it is very simple and straightforward. It is non-technical, right? So let us also take a look at the advantages and disadvantages of each of those probability sampling methods we told, okay. So cluster sampling, convenient. Simple random sampling, it is creates samples that are highly representative of population. Stratified random sampling, it creates the strata or layers that are highly representative of the strata or those layers in the population. Systematic sampling will create samples that are highly representative of the population without the need for a random number generator. So simple random sampling, we generally take the help of a random number generator. Okay. Some of the disadvantages include, like if it is for cluster sampling, then it might not work well if the unit members are not homogeneous. That is, if each of the members in the population are very different from each other, means cluster sampling will not work, because we cannot form clusters. It's like how do I explain this to you in cluster sampling? Okay, yeah, let us take a group of people. Okay, we have 1,000 people now, and we are going to cluster them depending on their profession. So maybe a few of them are doctors, maybe a few of them are teachers, maybe a few of them are engineers, maybe a few are managers, maybe a few are I don't know, maybe drivers. Okay, so then only we can classify, right? But what if there are 1,000 people, and thousand all those 1,000 have different what you can say, different professions. One is a scientist, one is a researcher, the other one is a analyst, the other one is an engineer, the another engineer, okay, one is a computer engineer, the other is a doctor, maybe the other is a sweeper, the other one is a maid, maybe the other is a businessman, one is a seller. You get the idea, right? Then there is no way we can cluster them, then it is a disadvantage. Okay, simple random sampling, it is very tedious and time consuming, especially when we have to create very large samples. Stratified random sampling, again, when we have to create larger samples, this also becomes very tedious and time consuming. And systematic sampling is not actually as random as the other random sampling techniques like simple random sampling, because we are choosing every nth person, and if suppose there is some way some harmonic way of what you can say, harmonic pattern, okay, in the samples, then that is like, if there is some pattern in the samples, I mean, then it will not be as random as possible, because we'll always end up in the same type of data, and will not have enough actual representations. Okay, I hope you understand that. Okay, simple random sampling, it as the name suggests, it gathers random selection from the entire population. Okay, so I'm not reading through it. This is just a written form of whatever we have been discussing so far. Okay, so this is a pictorial representation of the simple random sampling. We have, this is the entire population, and from that we are randomly picking up a few samples. So this is a sample space. Okay, so like for example, if we have 1,000 employees, and we need to select 100 employees from that, then maybe we can use a random number generator by maybe we have numbered the employees from 1 to 1,000, and then we are using a random number generator to generate 100 random numbers, means we will get this random sampling. Right now, when we are using this random number generator, there is chance that the same employee or the same random number might occur more than once. Okay, so for that also, actually we have two different types. One is if at all one number comes once, then we will not consider any other next occurrences, okay, of that sample of that same number. We can take it like that, or we can keep on taking the same sample again and again. Okay, so there are two different ways in that also. Okay, the next is stratified sampling, that is random quarter sampling. Okay, so in case you want to read through this material, pause the video and take a read. Okay, I will upload this PPT in our Telegram channel. So this is the stratified random sampling, where we are splitting the entire population into different layers, and then we are choosing from those layers. Okay, so for example, like if a company has 800 female employees and 200 male employees, then you have to make sure that sample reflects gender balance of your company. So what you can do is, you can divide your employee population into two based on gender. Okay, and then maybe you can select 80 women and then 20 men, which will give you a representative sample of 100 people, rather than choosing 50-50. Since there is a ratio being maintained in the sample also, we should maintain that ratio. Only then we will get a proper, or you can say a meaningful result. Otherwise our result will also get distorted. Okay, systematic sampling, as we said, it is the nth in sample of the population. Like if you have 1 to 9, maybe we'll start with 3 and we'll choose maybe the next third. Every third sample means we'll select the third, the sixth, and then the ninth, and this is our, what you can, this is our sample data. But now the problem, as I said, right, if there is a harmonic repetitive pattern, then it is a problem. See over here, we had males, but unfortunately every third person was a female. So if you look at the population, we'll think, if we look at the sample, we may feel that this population is entirely composed of females, right? But that is not the case. Like, even if you count the number of males and females, you can see that actually females are less in number in the population than males, but our sample we got, unfortunately, all women. So that is a problem in systematic sampling. That is the disadvantage we talked about. Okay, so that is the example also. Like, if you are all employees of a company are listed in alphabetical order, means how we can find out the systematic samples. Okay, so that is an example. Then cluster sampling, we randomly choose, say, 100 population, we randomly choose participants from our population. Okay, so that is cluster sampling. Like, for example, we have a entire, what you can say, this is our entire population. We just randomly choose people from this population. Like, maybe I want a sample of a person who is from, say, Agra, or maybe I want a person who is from the US, or maybe I want a person who has done BTech. Some random criteria, sorry, some clusters they will form, and then from that they will pick up the samples. Okay, yeah. So, like, for an example, if we can say, if a company has offices in 10 cities across the country, then we may not be able to go and collect data from all these 10 cities. So what you will do is, you will just maybe select randomly 3 offices that are near to you, and then so that will be your clusters. Okay, that will be your representative clusters, and you will go to these 3 offices and collect your data, and then you will train the entire complete data based on this sample you have selected. Okay, so those are the 4 different probability sampling methods and their types. Okay, so I hope this video was useful to you. You understood how you can tackle. What I want mainly from this for you to take away is how you can what you can say, cleverly or intelligently tackle your um, theory questions in this paper. That is what I want you to uh, you know create. That kind of a mentality is what I want you to create. Once you have that, and at least if you have gone through your book, right, if you have at least once gone through your book, you will be able to ace your exams. Do not worry, definitely you will get pass marks. It's not an issue. In case you feel that your problem solving skills are on a bit weaker side, I would strongly suggest you concentrate on the theory part. Okay, so the entire question paper you are writing for 100 marks. Out of that, so that will be equated to 70 marks. Okay, 70% is the weightage given to it, but at least if you can get 50 marks in out of this 100 marks, you will easily pass. Okay, especially since we all have submitted our assignments on time, you will definitely pass. Nothing to worry. So concentrate, use your strengths for your best advantage. Okay, suppose if you are confident with your problems, then focus more on that, but also focus on the theory, because we never know what problem might come. Okay, few very rarely only questions repeat. And MMPC 5, the textbook also, they have not given many sample or practice questions for numerical problems as well. Okay, so all the best, do well, write well. I'll try to make more of this. We'll try to discuss as much possible questions as possible as our time permits. Thank you so much. See you in the next video.